All right, so this is the Algebra 2 Academic 7.2 notes on rational exponents, okay? All right. So rational, let me screen mirror. Sorry, I got a cough. Let me get some water. So you got to evaluate 25 to the 1/2. Okay, so in general, the way we handle fraction exponents is you can rewrite them in a certain manner, okay? So this is 25 to the 1/2. I'm going to highlight my numerator of my 1/2 in red, okay? And I'm going to highlight the denominator there in blue, okay? So in general, if you have a number x, that's raised to the b over a, what happens is you can rewrite it in what's called radical form. That's that little check mark symbol here. All right, we're going to put our x in there. Okay? And our denominator goes in our root symbol right there. The denominator goes outside the little radical symbol, the denominator. And the numerator goes inside the radical symbol. Okay? So the denominator is the root. Use the acronym doctor. Remember that. The denominator is the root. Okay? So the denominator of my fraction is going to be the root symbol. Okay. So I would write 25 to the 1/2 as what? So let's do a little radical symbol. Which number, my denominator or my numerator, goes outside the radical symbol? The denominator. So it's going to be 2. So it's going to be 25 to the 1 rooted to the 2. This is just the same as what? If you root something to the 2, what that means is you do the square root, right? We want the number that we multiply by itself twice, right, to get 25. So that's 5. What's that? Yeah. Yep. Yep. Okay. So 8 to the 1/3, if we write that in radical notation, what would that be? So I have my 8. Does my 1 or my 3 go outside the radical symbol? The 3, yep, the bottom. The 1 stays inside of it. Okay, so we want the cube root of 8. Right, so cube root is a number that we multiply by itself 3 times to get the number inside my radical. Okay, so what number do we multiply by itself 3 times to get 8? 2, yep, so this is going to be 2.
So is that just the answer?
2, yeah. It is just the answer, yes. All right, 1 over 49. How do I deal with fractions raised to exponents? Yeah, so this is going to be 1 to the 1/2 over 49 to the 1/2. There you go. All right, so we kind of like distribute it to the top and bottom, okay? So the top becomes the square root of 1. The bottom becomes what? Square root of 49. Okay. So 1 over 7 is our answer. There you go. All right, any questions? All right, negative 8 to the 1/3. Right, so I can put negative 8 inside of a radical symbol. Okay, make sure you put that negative inside parentheses, okay? Make sure you keep the negative inside of parentheses. Does my 1 or my 3 go outside? Go outside. My 3 does, yep. My 1 stays in here. What number multiplied by itself 3 times gives us -8? -2. Okay? So in general, if you have a negative number, I'm going to write this on the left. If you have a negative number and you raise it or root it to by an odd number, that's going to give you another negative. If you take a negative number and you raise or root it to an even number, that's going to give you, rooted to an even is going to be no solution. If you raise it to an even number, that'll give you a positive. Very good distinction, very good distinction. Yeah, right? Right, there's no number you can multiply by itself an even number of times to get a negative, so that's not going to have a solution. That would call imaginary solution. Yeah. Yup. All right, E, number E. So I have a little time symbol inside my parentheses there, right? Remember 16x to the 6th? That's just 16 times x to the 6th, right? Because I have a multiplication symbol and not an addition or subtraction, I can do what with my exponent? Oh gosh. Give me another coughing fit. What can I do? You can distribute the exponent. So we can rewrite this as 16 to the 1/2 times x to the 6th to the 1/2. Oh, that worked out. 16 to the 1/2 times x to the 6th to the 1/2, okay? So let's think about what's 16 to the 1/2 going to just be. Raising something to the 1/2 is the same as doing what? Square rooting. Yep. And then x to the 6th to the 1/2. When you have a number with 2 exponents, how do we deal with those exponents? What do we do to make it 1 exponent? X to the 6th to the 1/2. We talked about this in chapter 4. When a number has 2 exponents, how do we change it so there's just 1? We multiply them together, so it's going to be x cubed. Okay, x to the 6 times 1/2, which is 3.
That doesn't go into square root?
Nope. We dealt with the square root. We dealt with the 1/2 when we multiplied. Yep. X cubed is the square root of x to the 6th. Yeah. All right. So quiz over this on Monday. All right, with no calculator. All right. All right, you guys want to go to number 2? All right. So let's talk about this. Let's talk about simplifying these without a calculator. Okay? So let's think about this. So 81, right? What number goes outside the radical? 4, 81 cubed. All right, so 81 cubed, just some mental math, right? 531,441, right? Not too bad. Right, what's the 4th root of that in your head? Come on, guys. No, I'm kidding. Sorry. Sorry. No, so here's how you do this. Okay, here's how you do this. Here's how you do this. Okay, here's how you do this. Okay? So to simplify the big ones, right, you start with the root. Okay? You can't do 81 cubed in your head. You probably can't. If you can, maybe you shouldn't be here. But if you can't, which I can't, you want to start with the root. So this time, what you want to do is you want to do 81 to the 1/4 first. So do 81 to the 1/4 and then cube that. Okay? And I can do that algebraically, right? Because when I have a number with two exponents, I multiply them. And if I do that, I get the original number back. Okay? So I'm just splitting up this exponent, doing the denominator first, and then I'm doing the numerator. Make sense? So what's 81 to the 1/4? What number that do you multiply by itself 4 times to get 81? 3, yeah. One way you can do that, an easy way to do that with like an even root, is you can do the square root of 81, get 9, you can do the square root again. That gives you 3. Okay, so that gives us 3 cubed. Okay, so 81 to the 1/4 is 3. What's 3 cubed? 27. Yeah, what's
When
up?
do you know when should I multiply the two exponents and when not to?
Yeah, so that's a really good question. Kate Moriarty asked me when we multiply the exponents versus when do we add the exponents. So if you have an x right here, and there's one x, do you see how there's one base? You only see x one time.
Yeah.
In that case, if you have x with a parentheses, you're going to multiply. So x to the a raised to the b is x to the a times b.
So the reason why we didn't multiply it on this one is because it didn't have x.
Wait, the one I just did?
Yeah.
We're doing something completely different, what I just did.
So it's just different.
Yeah. If you see x to the a times x to the b, right?
Yeah,
I see
yeah,
x twice.
yeah.
This instance is where I add. Okay?
So, but for this, it's just different sections.
Yeah. I'll leave that there, okay? Let's do b, -8. So what do I want to start with? This one's actually not too bad to do in your head. So let's start with that to the 1/3. So -8 to the 1/3, and then we're going to square that. Okay, so what's -8 to the 1/3? That's the same as doing what? Yeah, it's the same as doing the cube root of -8. So we're going to get -2 squared. All right, what's -2 squared? 4. That's my answer. Okay. What's that? I didn't need an I for that one. Because I can take the cube root of a negative number, I can't take square root. It's all about odd or even. Because that denominator is odd, I can do that with a negative number. Then that'd be notice. All right, 32x to the 2/5. 32x to the 5th to the 2/5. How do I want to start with this one? What are you going to do on Monday? Yeah, well, no calculator. Yeah, so how do you do it without a calculator? Yeah, so I want to distribute that 2/5, right? And I can do that because there's a multiplication symbol here. Okay? If there's a multiplication or division, you can distribute the exponent. You can't do that if it's a plus or minus. So I'm going to have 32 to the 2/5 times x to the 5th to the 2/5. Okay? All right, 32 to the 2/5. What do I start with? What do I do first? Can you do 32 squared in your head? Can anyone do that in your head? Actually, I might be able to do that. No, I can't. Would that'd be like what? I don't know. Maybe 2 to the 10th. Actually, I probably could. 2 times 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 2. Is it 2048? Anyway, you can't do that in your head. Don't try. Okay, so what do you want to do first? Do that to the 1/5 first. Deal with the bottom first, okay? So we're going to do this as 32 to the 1/5 squared. Okay? All right, then what does my x to the 5th to the 2/5 become? Bless you. You're welcome. multiply the two exponents, right? So it's going to be x squared. 5 times 2/5. 5 times 2/5. You should be able to do that in your head, okay? 5 times 2/5. That's the same as 5 over 1 times 2 over 5. Cancel these. You get 2. Okay? And then what's 32 to the 1/5? All right, that's the same thing as the 5th root of 32. What number do I multiply by itself 5 times to get 32? 10. 2. Thank you. Got it. So 2 squared times x squared, or just 4x squared? Good job. All right, we good? Let's do D. Let's do D. All right, who can do negative 16 cubed in their head? You can? Or no, you just waving? Okay. Okay, good. Yeah, I can't. So we want to start with what? The denom, yeah. All right, so it's going to be negative 16 to the 1/2. And then we're going to cube that result. Okay. What's negative 16 to the 1/2? So there's no real solutions. It's the square root of negative 16 for I. Yep. Okay, so this is going to be 4i cubed. What's that? What's 4 cubed? 4 times 4 times 4. 64, and then I cubed. What's I cubed? It's going to be negative I. It's negative 64i. What's that? Yeah, so do you see how we got to 64i cubed? Let's think about what I cubed equals, okay? So we get I times I times I. Let's multiply these first two together. What's I times I? Negative 1. And then what's negative 1 times I? Negative I. That's why that becomes negative 64i. Does that help? Okay.
Oh yeah, because I squared is negative 1.
What's that?
Because I squared is negative 1, so that's just
Yeah. I to the 4th is just 1. And I to the 5th is just itself. Okay. All right, let's move on to the next section. Okay, how are we feeling about that? So just make sure you start with the bottom. That's the only way to do this without a calculator. Only way to do this without a calculator is to start with the bottom, okay? All right, so let's do this one. This is just like what we did up here, except for what? Quick fix here.
negative 2.
It's negative, right? It's negative. Oh no. How do we get rid of negative exponents? Flip it. We good? Good. Okay. So we're going to move that to the bottom. We get 1 over 8 to the 2/3. Okay? So as long as I move my number to the other side of whatever fraction it's part of, I can make the exponent a positive when I do that. Okay? Man, sorry. All right, and then how do I do 8 to the 2/3? How do I do that? So let's deal with the denominator first, right? What's 8 cube rooted? 8 rooted to the 3rd. If I root it to the 3rd, it's going to be 2. This is 1 over 2 squared, or 1/4. That's my answer. right, B, what do I do first? Let's make the exponent a positive. What do I have to do that? Flip it. It's going to be 1 over negative 64 to the positive 4/3. Okay. And on the bottom here, we deal with what? The numerator and the denominator first in my exponent. Start with the bottom. Start from the bottom. Okay. What's negative 64 cube rooted? Negative 4. Yep. 1 over negative 4 to the 4th. What's negative 4 to the 4th? 256. Okay. If you have trouble doing that, just do write it out. Negative 4 times negative 4 times negative 4 times negative 4. Okay, this simplifies to 16. This simplifies to 16. 16 times 16. Okay? Do that by hand if you need to. Alright? Yeah, so that's our answer. What do I do with this one? Flip it. And that's the answer. Yep. Read your directions. It says write the answers. Oh gosh. Write the final answers with positive exponents. Okay. So this is my final answer. Right there. Alright, what do I do with this one? With D? A lot of energy in here today.
Do you just take the x up or do you have to take the 4x?
Very good question. Okay, so if you have, so our exponent here is negative 5/9, right?
Yep.
If that applied to the whole thing down here, if that applied to both 4 and x, there would have to be parentheses there. Since there are not parentheses, it only applies to the term that it's right next to. So we only move up the x. So it's going to be 3/4 x to the 5/9. Yeah. Yes. You may. All right, can I move on to the next part? All right.
So that's just the final answer there?
Yeah. There's nothing more we can do. Yeah, there's nothing more we can do. That's because the exponent's on a variable.
Yeah.
We can't do like the 9th root without knowing what x is.
So if it's only, so it's not a variable, you can change it?
I mean, yeah. What's x to the what's the 9th root of x? You don't know. You tell me. You tell me. Yeah, good point. All right, use the properties of exponents. Okay, going off Kate Moriarty's comment, right? There's 2 x's here, right? There's an x times another x. So what do I do with the exponents? Add them. Oh, there we go. What a save. What's 4/3 plus 5/3?
9/3.
9/3. What's 9 divided by 3? 3. There you go.
I have another question though, but for number A compared to number E, number E we multiply them together. Why didn't we multiply the 1/4 and the third? That's what I was asking.
So you could do that. If you do that, you just get the original problem back. So we're just doing that in reverse.
Okay.
We're doing that in reverse this time, right?
Okay.
To make the problem easier for us to do in our head.
So when do you know
You're
to do
splitting it
that instead of, how do you know that would just make it go back? Because then over here, you do that.
So you can do this in your head, right?
Yeah.
You can't do that in your head. So then you split it up.
Okay.
If you can't do it in your head, then you split it up.
So it's just up to you to do it.
Yeah.
Okay.
Yeah. I can do 81 cubed in my head. No, I'm kidding. Actually, I might be able to. 81 cubed would be what? 9 to the 6th? Which would, no, I can't do that in my head. Nope. Okay. All right, B. Same thing, right? So this is going to be y to the 5/3 plus negative 1/3. What's 5/3 minus 1/3?
4/3.
4/3. Thank you. All right, how we feeling? How we feeling? All right, can we do part C? Which one? B? There you go. There you go. Okay, let's do C. All right, this time there's a division symbol, right? Yeah, so I have the two x's that I'm dividing by each other. So when this pops up, remember chapter 5, you subtract the exponents, okay? You gotta do this by hand. 3/5 minus 1/10. Oh no. Algebra 1. Here's the algebra 1, or like middle school. Coming back to haunt you. When I subtract fractions, they have to have the same what? The bottom number has to be the same, right? How do I get those to be the same here? I got to multiply this guy right here by 2/2. Alright, 6/10 minus 1/10. Right? What's 6/10 minus 1/10 then?
1/2.
I subtract the numerators. Okay. Alright, so it's 1/2. Okay, so this becomes x to the 1/2. Remember to read your directions, right, with positive exponents. So that's my final answer. Okay? If they wanted it in radical form, it would be what? Square root of x. Right? Okay. Can I do D? Alright. There's a multiplication symbol, right? 81 to the 1/4. X to the 2/3, right? There's an implicit time symbol. So what can I do with that 3? Distribute, yep. So what's 3 times 1/4? 81 to the 3/4. And what's 3 times 2/3? Try again. So 2/3 times 3. These just cancel. X squared. And then 81 to the 3/4, we did that up here, right? Yeah. Ended up being 27. So I'm not going to go back over that. What's that? That's the answer. That's the answer. Okay? Can I do E? How should I do E? You want to flip the 1/2? You could do that. Yeah, we can do that. So let's do, it's going to be a to the 3/4 over a to the 4/3, a to the 1/2. What do we do now? So let's get it so that there's just a single a on top and a single a on bottom. So what do I have to do to the bottom to combine those? Yeah, so I have to add the exponents, yep. So 4/3 plus 1/2. What's my common denominator going to be? Yep. There you go, so e to the 11/6. All right, we're not done. What do we need to do now? Yep, subtract, thank you. So it's going to be a to the 3/4 minus 11/6. Okay, so 3/4 minus 11/6. What's my common denominator going to be? 12, thank you. It's going to be, what's it, 9 over 12. That's going to be 22 over 12. Negative 13 over 12. It's going to be 8 to the negative 13 over 12. I have to do what with that? Flip it. So it's going to be 1 over a to the 13 twelfths. Right. Part F. Can I do part F for you guys? You need more time. Alright, let's move on to F. Alright. What should I do first? What should I do first? So I would do, let's make it so that there's just one exponent in the bottom. So how do I do that? Yeah. 4/3. Okay. And then I do what when I'm dividing my x's? Subtracts. What's 10/3 minus 4/3? 6/3. There you go. There you have it. There you have it, kids. So use that on the SAT tomorrow. SAT math, I remember it just like I remember you do well if you just do it as fast as you can. That's the only way I did well. I did it as fast as possible. Math section? 7 seconds. 2 section, I guess 2 section, right? 2 section or 3 on the writings? 22, 60. You guys asked. Anyway, alright, let's move on. Let's do this last two. Alright, wait, these two. Oh, sorry, wait, these two. Let's do these last 5. Alright, how do you guys want to deal with this one? Don't forget. How do you guys want to deal with this one? What should I do first? Yeah, so let's distribute that 4, okay? So it's going to be 3 to the 4th, x to the 4/5 over x to the 3/10. Okay. So in general, you want to simplify the side that's more complicated first before you deal with the fraction. Does that make any sense what I said or no? You want to deal this side's like more complicated, right? It's got 2 exponents, it's got parentheses, I mean that's complicated. So try to sort out the top first before you deal with the bottom. Just ignore the bottom in your first step, okay? Right? What's 3 to the 4th? 81. Okay, and what do I want to do last? Leap. Is it last leap? Yeah. Yep. So this is going to be, remember, the 4/5 exponent only applies to the x because we're missing parentheses. All right? So it's going to be 81 x to the 4/5 minus 3/10. What's 4/5 minus 3/10? It's going to be 8 over 10 minus 3 over 10. So it's going to be 81x to the 5/10 or 81x to the 1/2. What should I do down here? What are we going to do in the quiz on Monday? What should you do when you see this? So kind of complicated with those parentheses, right? Let's try to get rid of the parentheses. How do we do this? Distribute, yeah. Try to make the problem simpler one step at a time. All right, I can distribute on the bottom. All right, what do I do now?
What did you get rid of the negative exponents?
You can, yeah, you can. Want to flip? So I got to take this b to the negative 1/4, move it to the top. Take this a to the negative 3/8, move it to the bottom. Did you finish the test? Thank you. So now I have b to the 1/4, b to the 2/8, all over a to the 3/8, a to the 2/4. Okay. My last step is what? How do I combine b to the 1/4 times b to the 2/8? What? No, I'm not. Oh, yeah. Okay. You're jumping ahead. I'm going to add those exponents in the top. Okay. So that's going to be what? B to the 1/2. If you do 1/4 plus 2/8, you get 1/2. And then in the bottom, you get a to the 7/8, right? That's what I got. That satisfies my instructions. Right there. Okay? All right, let's do these three real quick. Use rational exponents to simplify each radical. Okay, so now what we're doing, right? So this first section up here, we started with exponents, with fraction exponents. And we rewrote everything with radicals with the little check mark symbols. Now we're going backwards, okay? All right, three more, guys. Bear with me real quick. What is this as a fraction exponent? All right, so up here, which number went outside of our radical? Right, the denominator always went outside our radical, okay? So going backwards, the number outside our radical always becomes the denominator. So it's going to be a to the 4/12. Simplify it. Simplifies to a to the 1/3, okay? All right? All right? All right? Okay. What's this become? So let's do it like this. Rooting a number to the 12 is the same as raising it to what exponent? To the 1/12. Right? And then what can I do with this exponent? With the exponents? Multiply, right? So it's a to the 6/12, b to the 6/12, or a to the 1/2, b to the 1/2. Right? And then last but not least, you do the exact same thing on this problem. Okay? So it's going to be x to the 8th, y to the 4th, raised to the 1/12. So x to the 8/12, y to the 4/12, x to the 2/3, y to the 1. Any questions? Comments? Concerns? All right, good stuff, guys. We got through that way faster than we did in F period.